And I'm just going to start. There we go. So welcome everyone to this month's Net Liverpool event. Can you all see my slides? Just give us a nod if you can. Again, just want to let everyone know this session is going to be recorded for our YouTube channel. And below you can see some of the sort of Twitter handlers and social media handlers we have. So you can visit our YouTube channel and catch this tomorrow. We've got a meetup page which you've probably all signed up to get this link to see our next events next month. We run monthly, we usually run the last Thursday of every month. We've got a Twitter page where we're going to be posting some updates there as well. And we're trying to keep things open source. You can visit our GitHub page for any code demos and stuff as well that we like to share that we work on these meetups. We're part of this .NET Foundation. So if you run the meetup page, do check out all of the other meetup groups that are on there. There's quite a lot. And everyone runs all these different .NET based meetups every month, and there's loads of cool ones to check out on there. These events wouldn't be able to take place if it wasn't for our sponsors. Normally we get together, in Liverpool. We're a Liverpool-based group. We've opened up virtually at the moment, but thanks to our sponsors, they allow us to do that. So a big thank you to TLA, who are also recruiting at the moment. So if anyone's interested in doing any .NET backend jobs and working with some of these technologies that we're going to be looking at today, just drop us a message and we'll get in touch and hopefully that works out. We've also got JetBrains as one of our sponsors as well. They're going to they've enabled us as well to give away a product license today. So if you're interested in joining a raffle that we're going to be giving away at the end of the session, at the end of the presentation, you could win yourself a JetBrains license. And there's a lot of products involved in these JetBrains licenses, to ReSharper, to .NET Trace, and we'll so yeah, do check them out if you're interested. Just drop us a message within the chat and we'll add you to a raffle at the end. We've also got some other groups I want to point out as well that are the local to us is Mini Hack, and they're doing virtual meetups at the moment where they're literally being a bit more hands-on and going in and sort of hacking code together. They've had some great meetups there with some very famous devs as well to promote it. So if you want to get away from sort of this virtual presentation where you're just going to be watching, if you want to get a little bit more hands-on, do check their group out. It is a really good new group that have started there. And just to make everyone aware, we do want to keep this interactive, and we do want to publish this on our YouTube channel to help everyone in the future as well know who we are and expand. So even though we can keep interactive, if you feel like you want to, obviously you can keep your camera on, or you can unmute your microphone or leave comments, and we'll try and pull you in. But just watch obviously your language and stuff like that, so we don't have to edit the video and spend loads of time trying to edit it to get it onto YouTube. And that's it from me. So I'm going to hand you over to Idan, who's going to take us over to the presentation and the demo side. So thanks, Idan.
Thank you for having me. And I think you need to stop sharing in order for me to share.
Yes. Now give me 5 minutes.
Find the button. Yes.
There we go.
Awesome. Thank you very much. Thank you very much, Joshua, for inviting me here. And I really hope to make this like an advanced session, like John asked. And in order to do that, really make it interactive. I was born in Israel, and we are very like to interrupt people in mid-sentence. If you allow someone to finish the sentence, it's considered rude. So if you have a question, just go and ask. And I would like to make it more like an interactive and really to take it where you really want to learn about it. Now, just to tell you a little bit about myself, you already know where I grew up, but I'm a developer advocate at a company called Ozcode. And what Ozcode is all about is, for me at least, is redefining debugging. And I just find it really hilarious that software engineering have all kind of saying like it's not a feature, it's not a bug, it's a feature, right? You don't hear it in construction, right? If you cannot get into the house, it's not a feature, it's a problem in design. And because debugging is hard, and Ozcode over the years create this really awesome Visual Studio extension that really allow you to give you like a superpower as a developer to really help you debug things. And we will not really talk a lot about that today, but we will show later at the end about production debugger. And it's really a really cool tool to really help you debug production. And why is that? And why related to Docker? So today, what I really want to chat with you about is how, as a .NET developer, you should address debugging Docker. Um, and it's a different world because Docker can support many operating systems, many languages. And what we found out while talking with clients doing those transition into Docker and containers, for .NET developers, it's sometimes can be scary, and sometimes a lot of them just wait until they must, right? So that's why when we decide this talk, we really want to make this introduction to what is Docker, but in the view of a .NET developer. And if you use Visual Studio, you will be fine. But if you actually know Docker and you're already using it in your day-to-day, I really hope that by the end of this talk, you will learn, I may be able to teach you one quick nuggets of how to make your life a little bit easier when it comes to debugging Docker. So with that, let's dive in. So if you want to understand Docker, the way I will try to express it is really to go a little bit deeper of how things actually work, but also try to correlate it to other things that you probably already familiar, a virtual machine. And I will compare virtual machine to Docker and containers and really explain all kind of small tidbits that are interesting for .NET developers specifically. So let's start from the beginning. You have a server, a metal that's running OS, probably Windows if you're using .NET, and you want to run virtual machines on it. The first thing that you will need to do is to install something called hypervisor. It's basically a small software that allow you to create those virtual memory pools and CPU pools that you can then load an entire operating system and then probably some application that you want to run above that operating system. Now, as you can see in this slide, there is a lot of OS appearing here, and that seems a little bit wasteful because what is really an OS today? It's basically give you some basic functionalities like processes, threads, file access, network access, all those type of features. And most of them do it very, very, very similar. And that I think the major innovation where Docker or containers came. And the idea here is what we really want as developers is just those applications, but we want to run them on a different VM for all kinds of reasons. So instead of actually loading the entire OS, what Docker Engine actually does, which is really clever, basically creating a small wrapper that look like that hosting OS, and basically will channel that to the local OS API. So managing processes, file access, all those kind of things. And this is genius because if we can just now load much more operating system, but not really have too many operating systems running on the same server. And you can actually really save tons of memory and then loads more applications and basically have like a miniature of a VM. Now, as you can see, those guest OS have different sizes. And that is for a reason, because that is something that I really want to mention here when you use Docker as a .NET developer. Alpine OS, for example, it's almost like a bare bone operating system with no cool, weird features that usually other operating system has. So it's extremely small image. So the footprint of the Alpine OS, it's extremely small. And as you can see, Windows to scale is huge, right? When you try to run Windows OS as a guest operating system, or basically if you try to use .NET framework inside a container, there is a price to pay. And the reason for that is because Windows OS and specifically .NET framework bringing a lot of legacy things into the system, which some of them are really cool features like registry, Windows management, WPF, WCF. There is tons of stuff that come with the operating system. And that is a problem because in order to mimic it, you actually need to load a lot of those services inside the guest OS, which as a .NET developer, you really need to make this decision early on in your Dockerization process, right? And basically, if you want to run a .NET framework, just to load a .NET framework, you need to load a lot of supporting .NET Windows operating system features. So the container actually need to be a Windows container. It's not a Linux-based containers. It's a different beast. And the container image, and we will talk what that is all about, it's large. It's around 2 gigabytes. Now, there is another versions like Nano Server and Server Core for containers, but the problem with that is basically what they decided to do. We will not ship all the feature of Windows. We will ship the bare minimum to make things work. So sometimes it's something that you can use. Sometimes it will not really allow you to run your legacy .NET framework. And that, for me, as a rule of thumb, you will need Windows container if you have a legacy .NET framework that you want to containerize. Just know that there is a price to pay. However, if you can port your code to .NET Core, well, .NET Core can run almost every operating system. So the containers are extremely small. For example, you container of 200 megabytes with full ASP.NET Core inside for hosting, which is way, way better. So future development, probably .NET Core, legacy. Any questions so far? Awesome. So let's talk about what images are. And again, we will talk about how VM runs and the cycles of a VM. And then we will just compare it, how it's looking Docker and what the differences are. So when you want to start a VM, the first thing that you need to choose is the base image. If you use any cloud service, that is the first question that they ask you, what image do you want to boot, right? Basically, it's like an install disk, but it's a little bit more efficient than that. And then you start your VM instance. And you do all kind of things, do run Windows update, install some feature, install some application. And then at some point you want to freeze this image because you want to keep it, maybe you want to revert it back late down the line. So you want to hibernate your VM. And basically what that called is a standard checkpoint, which is basically, let's store the new VM image and also let's dump all the memory. So then you can always boot from that exact same moment. There's a little bit catch up because time moved on. So when you boot it, well, the clock will jump forward. And if your application doesn't really handle that gracefully, that could be funny. Now, what people actually thought about, the changes that you're doing to the VM in this new image probably are not a lot compared to the original image size that could be several gigabytes. So instead of actually storing the entire disk again, we're storing delta. What blocks on the disk have changed. And I repeat that, blocks on the disk and not file system, because a VM actually make the entire things virtualized, including disk and network address and all those kind of things. Everything is being simulated or virtualized. And then you can do it again. You can install some few more maps and create another delta. Now, another checkpoint. And that delta is actually pretty clever. It doesn't store the delta from the original image. It will store it from the image before that. Now, at some point, you will actually like to turn your VM down. And then you can actually create what they call a production checkpoint, which is very similar to the base image. It's basically just the state of this disk when you shut down those VM image. And when you start to boot from that, it would actually boot the entire system, right? Instead of a standard checkpoint that would actually start from the middle of an execution with running process already. And that is very important because Docker images are extremely similar to production checkpoints. So one thing that you need to understand before we move to Docker is that every time a VM make a disk access, it would actually go down the pipe for all the checkpoints. So you say, hey, someone tried to read this block on the disk. Do you have it in the current state, which is the read-write version of the disk? And if it doesn't have that block, it will go to the second delta, to the third, and then go to the base image to load it. So that is something to keep in mind. If you have a lot of checkpoints and your VM becomes slow, that might be the reason you might want to merge those deltas so you will have fewer of them. Now, Docker image is really similar, but with a difference. And the difference is that we don't really virtualizing the disk. We actually use the disk structure of the hosting operating system. So instead of actually having all the blocks that change, we just need to say what changes happen to the file system. And that is pretty cool, because if I created a lot of files and then I deleted a lot of files, the changes could be very small. However, on the disk, it's a whole different world because blocks moved around. So that's why those could be actually compressed. Even more, if you're running two Dockers on the same machine that actually using the same Docker image, that entire disk state could actually be shared in memory. So you get these benefits of that as well. Only the container layer, which is the read-write changes that actually happen while the container is running, is being duplicated. Questions so far? Awesome. So let's go up to the other thing, and that is a Dockerfile. A Dockerfile, I think, is really cool because that really gives the secret sauce of how do you create those images. It's not like a VM that you need to run and maybe do some manual labor. Docker is really all about creating those Docker files that really explain the Docker build system, how to build your images and then run them. However, we will go into depth what that actually file look like. But before that, let's just dive into Visual Studio, because as a .NET developer, probably Dockerfile will not be something that you really need to look into. And why is that? Because if you will just go, for example, I have here a simple ASP.NET Core project on Windows. And if I want to add Docker support, the only thing that I need to do is go add Docker support. And then I need to choose if I want a Linux-based or Windows-based container, and we cover that. And as soon as you do that, you will actually get this Docker file. It's a multi-stage building and all those, all kind of cool features. However, it doesn't really matter because probably it will be just right and you just run it. But now that we talk about that, it doesn't important, let's just read it just for fun. So we will just focus on that section and really try to understand what is going on here. So this one is from some kind of a .NET Core 2.2 in this example. Basically, we're choosing the base images we want to start our Docker to run from. Then we have this copy example. That will actually copy a file from the host operating system into the Docker operating system. And every command that you see here would basically will run the operation that we have here, like this, .NET restore, that basically installing all the NuGet packages. And what Docker actually does in the background is starting from the previous image that we just created, run this command, and then shut down the container, and then look at all the file changes that that container did, and create a new image from that. And then go until you get the final image that you can actually start run. Any questions around that so far? Awesome. So with that, let's just go and see our victim of the day, which is we are going to debug this example, the superheroes night school, because everybody need some adjustment after COVID. And this is a simple microservices example. There is several services here. And the entire thing here is basically an admin for the night school to assign courses to, and we can do that. We can assign courses to the right rooms, and there is a room service that capture which rooms are being used by which course. And here there is a small status page that is just running. And what we will try to do here is trying to debug it. And just for your knowledge, you see here it's actually running all those containers running on my local machine. So if I will go here and do Docker PS, you can see we have several Dockers running here. Now, how do we do that? The problem with debugging containers is when you try to debug a normal C# application that's running on your same operating system, Visual Studio actually uses the OS debugging API to do all the magic. Add breakpoints, inspect the memory, inspect threads, and all those kind of things. The problem is when we actually go to containers, it's no longer the case because our process is now running inside the container, which really open up remote debugging. So let me show you, if you want to debug a local container locally on your machine, what you need to do. So you just go to attach process, touch to process. Now, usually what attach process will do, actually, let's go back to default. You will actually get all the processes that are running on your machine. However, lucky for us, we got this Docker connection type, and then I can click find, and I see all those processes. What actually basically happened behind the scene is we actually running the same command here. Give me the list of all the Dockers that I have. And we will use service A. Awesome. As soon as I did that, you see that now we get a list of processes inside the Docker. How that actually happened, it's basically same thing as do Docker top and Docker service A1, which is the name of the Docker. And you will actually see what processes actually are running there, which is very important because we are going to do attach. Actually, another thing that you need to do usually is to select if you want do native debugging or managed. So we will do manage, you click one and then you click attach. And now you see it's say launching debugging adapter. And that is pretty cool. And what is actually happening? And we will just give it a while until always when I do demos, Visual Studio froze on me. So let's see what will happen today. Actually, let's see if we can already start inspecting what is going on. Yeah, so now when I did again, and I think we hit the breakpoint, yes. So we now get a full debugging experience inside Visual Studio, the debugging process inside the container. And as you can see, I can do step over and I can go here and inspect memory and see all the courses. And you see here, it's have some schedule and there is lecture rooms and practice room and how many was scheduled. And you can just go and continue debug it and see all those kind of things. But how this actually is working. So let's just look at the processes that were actually created inside the process. Basically what Visual Studio does for you behind the scene is using the command docker exec, and I will make it interactive, and docker service A1, and I want to run bash. Basically, docker exec actually allow you to boot a new process and then connect the STD and STDIO channels to that process. So I can do ls and see all my files, right? I can even do, for example, cat web config and see everything inside the container. And when I'm done, I can do exit. And that is exactly what Visual Studio did behind the scene. Now, there is several processes, but basically just a script that called get vs debug that actually install and copy some more files into the Docker container. And then it's
question
here.
Yeah.
Sure.
What?
I can't hear Sarah anymore.
I think you carry on. I think she unmuted herself by accident there.
You might want to maybe type it in the chat if we can't hear you. I would love to answer your question.
For Dynatrace, all of those things are supported. We have done the
I heard that something is get supported by Dynatrace, but I couldn't hear more. So let me continue, and Sarah, if you can ask again, I would love to hear your question. So basically what happened here is we are installing VSDebug inside the container, as you can see here in root.vsdebugger. And that entire thing is actually running using the std-ion channel and basically using booting a VSDebug inside the container and communicate with it. And I created a nice visual for you guys, which is something like that. Basically, it will create an std-io channel to your local container and run a VSDebug that will actually debug your application. So it's still a remote debugging, but everything running on your machine. So you will see some performance in terms of the speed of the debugging itself, but still you get a complete full debugging. Now, one thing that I would like to mention is what happened outside. As you can see here, there is this loading, spinning loader, because the UI itself still waiting for that web request to be completed. And as you can see here now with this get status that basically do some basic health check, still waiting for us to finish the debugging session. And what I will do, I can just press play and it will now jump again, right? Because it will do it again and again and again. So I will now just do debug detach all, and we will stop this debugging session because I really just want to talk to you about these implications of debugging a container. Now that we understand how a container actually get debugged, let's understand the implication of that. So when you're debugging your C# application, basically what you do, you stop the process, right? All the threads are frozen, memory is frozen, and now we are debugging and inspecting what is going on. However, the container itself is still running. The container is happy as it could be. So from the outside, it's basically look like your C# application is frozen. And that actually causes a problem, because what if another process is trying to call it? And in our example, the UI was trying to get the status and couldn't. It just wait and wait and wait and wait. That actually started creating bottlenecks. And now this container could be frozen as well if that was like a complex across microservices. That could actually make this service frozen because you're trying to debug a different service, which can now cause a cascading error effect. So that is something to keep in mind. Another interesting thing, I'm using just Docker Compose, and just for serving resources on my machine, I have every service have just one instance. However, if you want to get more stability and scalability, probably you will use an orchestrator to run several instances of every service. So you're now connected to one agent, not one container, and you start debugging it. The orchestrator would actually continue running health check to all the containers, see how they're doing. And after a while, it could actually say, hey, that container stopped responding. I would stop send traffic to this container. So now you started a debugging session, but you cannot continue because well, no new traffic is getting to this container. Even more, some orchestrator will decide, hey, this container is not behaving. I would restart it. It will kill the container, close your debugging session, and we'll start it again. And that is really the problem of, I would say, trying to get over one small container. And maybe if you control the entire system, then great. You might be able to jump between those two containers, but really go to like debugging like a multi-services, multi-service. Oh, cool. I answer your question right after. You will need to tell me at the end what was the questions, because now I'm curious. So just to summarize what the limits of debugging a container. So you're freezing your process inside the container, which can start creating all kinds of side effects while you're trying to debug the system. And I think I mentioned all of them here, so I will not go over him again. But it's really the main issue here, and that is what we really trying. If there is one thing that I would like you to get from this talk, is this next slide, and that is all about maybe we are doing debugging wrong. And I think what the demo that I show you right now, how you can debug a container inside Visual Studio, it's what I call intrusive debugging. And we're trying to do two things when we are debugging. We're trying to extract information from the system. Basically, what statement, what are the local variables, what are the threads, what is the call stack, all those type of information. And then we try to reason about it. How the heck did we get here and what went wrong? And the problem is that extracting the information happened in computer speed, happened pretty quickly. But then reasoning about it happened in human speed, which is way, way, way slower. And we're trying to do them both at human speed. So non-intrusive debugging is basically, let's try to extract all the information that we need in order to understand, but without freezing it. So basically collecting the thing that we want and then reason about it after the fact. Now, non-intrusive debugging is not new. Everyone that learned coding anywhere on the planet do it. That is the famous console write line, right? The first program that we all did is write line here, I got here, I got here, I'm not here. And usually people fall into that when they actually couldn't just a debugger, which basically we got the next level down and we actually decided to create logs. And after a while, we even got really good. And if you use Serilog, for example, you can actually store structural logs, which are, you're not just storing lines of string and then you need to parse them. You actually store the raw template that you want to send to the logs. And that gives a complete ecosystem of how you search those logs. And we will see that in, actually, let's see it. So I got all those services here, and all of them actually sending information here. And let me just refresh the page. You can see all the log messages that they actually sent, what is going on here, everything. And if I just open one, you can see that this is the message, right? But this is all the arguments. And now I can do, for example, I want to search all those action names. So I can do find, and now I can see all the log messages. They do not have to be the same log messages, but that property was true, which is pretty cool. Sec is just an open source Docker that I just attached to my processes. And I'm using Serilog to then send every log message that I do to this unified location. So all the services report the same thing here. Now, Now let's do some scheduling stuff. And this seems to work amazing. And something bad happened, right? That is where things start to be hard. So actually I can go and just refresh, and I can start see that there was some errors, and I can even see some call stack and things like that. Now, another thing that is really cool, I can also see the trace ID, right? And that is really the third level of non-intrusive debugging, and that is open tracing. And that is really important when you try to do when you try to understand your system that is composed of many microservices. Then every time a transaction happens, basically the basic idea is to add a header, right? Or something that can write with the request themselves to the database or to other services, and then store the transaction ID. And then you can actually use your logging system to say, show me all the messages just for this transaction ID. And they can come from one service or the other service, but you can actually see what's actually happened during that transaction ID. And actually open tracing is actually become a standard, and there is a lot of services that actually use the same protocols and same headers. So you can actually build a complete picture after the fact of what really happened. But we believe there is a better way, and that's where the cool things, at least for me, start happening in this talk. And that is really to talk about production debugging. And because non-intrusive debugging have one catch that you need to resolve. And that is this paradox that if you knew what you want to log, then probably you already know the bug. And that's what we see in a lot of organizations. And that you try to log everything because you want to have this perfect traceability of what went wrong. But then something went wrong and you don't have the right log message. So what you do, you deploy a new version with another log messages. Hopefully now you will have the information that you want, right? And it's go over and over and over and over again. So that is the inherent problem of logging, I would say. And production debugger really try to solve this. And in order to explain how it's actually solving, let me introduce you to Osgood Production Debugger. So this, I also install our agent in all those Docker's containers. And we are using the .NET Profiling API to attach to your process. Now, the agent itself is extremely passive or lazy. It doesn't do anything unless exceptions start happening. And as the first time an exception happened, then the agent would actually inspect the current call stack of that exception and will add instrumentation to only that specific call path. So then when next time this exception happened, we would actually have a complete recording of that exception. So in order for that, let's just call this again, and we got this error. Now, what happened on the agent, it will now have the same execution, but this time with our unique instrumentation. And then we actually can record that exception. And if I would just go and refresh it, you can see that now it's been captured. And that is so after it was captured, the agent then removed the instrumentation and your code go back to normal the way it was. So let's try to debug what's actually went happen. So there is a lot of here. So let's just go, let's just start with the code itself, right? So you can see this is the line of code that actually caused the exception. But you can see that we also show you this entire stack. And you can really nicely just scroll up and see how did we get here. From this one, which is the method that actually, the handler, how do you call it? The controller method action? I'm not sure. That is where the HTTP request started. And then it would actually do all those kind of things. And the top here, if you know application insight, you can actually see that this method actually calls a service B that return 500. So that probably were actually this is probably the root cause of what's really going to happen. But we can actually see that the exception that was actually thrown here, that no available room found. Now, as you can see, as I zoom up and down, I scroll up and down, you see those, I can see all the locals that were captured when that exception actually happened. So you actually get a full experience to debug exactly what happened with the number of teachers, students, well, features is empty. So, and actually, let's go back to see what happened on the other service B. Let's debug this one. So here it's there is almost no call stack. And you can see there is a null reference exception here. And we can see here that features is null, which is extremely weird because, well, we got a default value of an empty string. And that is really a really simple example, but just to show you the power of production debugging or container debugging in this example is we, as a developer, I thought that, yeah, I'm safe. If you don't provide any value, it will be empty. But that is not the case because there is actually third-party code that would invoke your function, right? And that was different, right? And as you can see, the agent is smart enough to detect what is your code and what is third-party code, which is popular NuGet packages. So it will actually then focus you to the problem that you have. So now you know how to fix this bug. Now let's go back to the other error because I really want to show you another cool feature. And that is sometimes we know that we get here, but there is all kind of if statement, and I'm not really sure how we really get to this line. A lot of time understanding a bug is not really see what's happened when the bug was thrown. That is where the system already been in an invalid state, but you want to go several steps backward to really see how we get there. And if you really need this information to resolve the bug, we have this big button here to actually ask a full-time travel recording. And as you can see here, it says that it's now been capturing. And if we will go back to the errors, you can see now it's in capturing mode. So we will go and do it the third time. Now, the difference between lightweight, what we call the automatic capturing of every exception, and the full-time travel is the full-time travel would actually record much more information for you. And we try to visualize it by showing you like a movie icon. And let's see what is the differences. So this is with time travel. This is without. This is with. You can see this visual language that actually describe how did we get here. If these are all kind of questions, I will answer them as soon as I finish this part. Now, what this visual language is all about, it's actually show you how the code was executed and got to this line. So you can see this if was evaluated to false. So we highlight that in red. So then we actually can tell you that this code was not run. And this one is evaluated to true. So this one was not even evaluated. And this is not just for this function. You can actually go and see the entire things from the beginning of the web request until when you actually get there. And you can see those head-up display, how those values, if they change over time, what the value were. And if you're familiar with our ID extension, then you will feel right home with these visual languages. That is basically the root IP that enable us to do this full-time travel capture. Now, even more, all those web requests, you can actually get all the request and response headers. And if that was a JSON or not a failed request, like a post request, you will actually see the fields in the post request. So you can actually see everything that happened during that specific web request, which is also very important because you can see here the logs. You can see that we only show you the logs that are relevant to the current request. Unlike trying to figure out logs here that they are from the entire system, what we do here automatically, the agent will do it for you. If you're using some common logging framework like Serilog, Log4Net, and or the Microsoft logging extension, it would actually then capture all the log messages that happen in the same async context of that web request and only will show you that. So basically what we're trying to create for you is the perfect bug report. Exactly what the state of the system was from the beginning of the web request until when everything blew up in flames. And with that, let's go over some questions. Okay. Presumably, you get this level of detail require PDB files. Oh, that is a great question. Well, how the heck did we get this code? Because when you will install the Oscode agent, you don't need to do any modification for your code. It could be in release, doesn't need PDB files, you don't need to connect to source control. What you see here is a decompiled code that was actually running. So that is pretty cool because sometimes you can actually learn how the compiler optimizes your code. Now, sometimes you will actually get some loss of information. Well, function names and things like that are actually stored in the IL. Local variables, some of them would actually be in the IL, some of them would just be a generic name, like, where was that? Room 2 in this example, right? That is not the original name, but that is what we got here. If you have PDB files, then the agent would actually start to use them to recover missing local arguments that actually were completely optimized and moved to a register and stuff like that. So I hope that answered your questions. Where do you get the code? Debugging production environment using the Oscode, yes. I don't recommend you connect to remote debugging session to your production environment, but you can actually do it with Oscode. And that is a really big point that I really want to mention, is that when we capture this state, we just instrument that specific function. We are not freezing the entire process, which is, I think there was another question, it's look faster than application insights. How do we integrate this? Is this part of the Docker image? Yes. So several questions here. Yes, it's part of the Docker image. And if you will go here and do install an agent, you can do my host Linux Docker. You will actually get the full instructions with that specific piece of code that basically do two simple things. One, put some binaries inside your images. I think that is like 10 megabytes, extremely small. And then set some environment variables. You see here, there are actually basically telling the .NET framework, or actually .NET Core, to load our profiler to your process. And you're done. That is basically it. You can also use it on Azure and other kind of cloud services. And you can also install it on your VMs if you're using IIS and stuff like that. So if it's run.NET, probably we can debug it. Now, it is faster from Application Insights. Application Insights have similar feature. It's called the snapshot debugger. And it does something a little bit different. The snapshot debugger is actually a pretty cool idea. I have a different slide of how you can actually do debugging in productions. So what Application Insight does behind the scene is when they get an exception and they want to capture it, they actually fork the process and create a mini dump on the fork process. So that the entire thing takes a few milliseconds to start forking. And also you get some performance because now all those pages are copy and write. And there is a bunch of things. But the main issue is the size of the dump. Because you actually capture the entire process, which give you really cool features because you can actually inspect the entire heap of the process, which is very valuable for some scenarios. But that's why you have a limit in Application Insight. I'm not sure what the limit is today, but last time I checked, it was like 50 snapshots per day, right? But with Production Debugger, you can have thousands of exceptions because those snapshots are only capturing only this small piece of code and all the local variables inside that piece of code. Is the agent is decompiling in production libraries DLLs? Wait, maybe that is a Docker image. Okay, it sounds like a great performance. I assume it doesn't have too much overhead on the image itself. Well, no, the image itself would be 10 megabytes larger. Another consideration is in terms of performance, and the agent itself have self-throttling mechanism. So we guarantee no more than 3% CPU when the agent actually doing stuff, right? If no exceptions happen, or the exception happened for the third or 15th time, the only thing that we actually do is just capture and report to you that there was a new occurrence of that exception, but we don't create more and more snapshots. So it's really lightweight. Next question. Is the agent is decompiling in production libraries in DLL? What sort of performance impact we would be looking at? Also, is security implication because of we are using an agent? Yes, awesome questions. So in terms of performance, actually, I want to show you one more feature that will make this question, this answer even better. And I will try to also deal with security while I'm doing that demo. How are we in timing? Sorry, Joshua, I think I will need a few more minutes. If that is okay.
Oh, that's fine. Yeah, carry on.
Awesome. So we saw a problem when an exception happened. That is great because the system told us, hey, something wrong happened. Sometimes it's different. We try to schedule this course and we got rooms assigned, but no student. That seems to be weird. What the heck is going on? And if you try to refresh here, the last thing that happened was 9 minutes ago. So no exception actually was causing that. So in order that, now we really want a debugging session. And for that, we have trace points. Let's really go back to performance. So trace point session. Why we have sessions? Because we have one production system and many developers. So every developer can have its own session, and each session would actually only record the information that is only important for that specific feature or debugging issue that you're trying to understand. So where we do that, so here we have this really nice code exploring feature of all the loaded symbols in your agent. So we will go to course controller. And as I click that class, it would actually decompile that specific symbol. And you can now see it. And actually, I want the resolve schedule. Yeah, we jump into that, like you're inside Visual Studio, but on the web. And let's just put a breakpoint, or we call it trace point because it's a non-breaking breakpoint. So we can say we got a new schedule for, and I can use these curly brackets, really similar to how we are doing that for Serilog. And I will just use the ID, which is basically the calling course ID. And that would be it. So now I actually created a trace point definition. Nothing really happened until I click this button, start collecting. And when I hit this start collecting, that is awesome. Okay, it didn't report that it was collecting. Maybe it's lost connection to the server when it was demo. But now you can see that it's actually been start recording the session. So when I hit the recording, only then the instrumentation to that specific line of code, if you go here, would actually be added. Now, I can actually go here and do a schedule. And actually, I think I added twice right now. That's interesting. So we can actually see this trace point that got hit with all the local variables and the message that we just created. And now you can actually see that there was no lecture rooms. So maybe the problem was in the debugging session and in the room controller. So I can just search rooms controller and it will load me that. And maybe the problem was here that there was no rooms with features. Awesome. But here we can say we found rooms with features. Amazing. Now, because the session is being recorded, then all of those things would actually happen at the same time. So I would just go and run that schedule again. And we can now see that we got messages. Actually, let me add those contextual data. I want the service name, and I also would like the correlation ID to show you two things. So let's just pause for a minute what we actually did here. We actually did a debugging session from a live environment without shutting the process down, redeploy, and we did a cross-container debugging. And we can see we got service A and service B, and we can actually see this correlation ID. Now, this correlation ID would actually get added automatically for you if you just install the agent. It would actually inject those HTTP headers to the web request. So even if you don't implement yourself open tracing, you get it out of the box. But if you want, you can integrate, for example, with application insight. Okay, with application insight. And for example, here I have a trace ID that you can now correlate it to application insights. And you can do it with Datadog, Logs.io, any other system that you want to integrate with. Now we can see that we did get both rooms. So there was no problem of missing rooms. So where really is the problem? So if we go to the resolve schedule function again, we can see that lecture rooms actually come from find available rooms. So let's just go to find available rooms. And we see here there is this warning, failed to find available rooms. So we can actually search it here, failed to find. So we already hit that, but this is the only information that we actually get from that log line. So let's do something pretty cool. Just let's put a trace point here and ask why. And let's run it again so we can capture it. And let's go back to sec and refresh. And let's search why. And we see we got that log message here. But this is different. Well, there is several cool things that happen here. Let's just pause it. First, I use this integration that every time I add a trace point, it's also generated a log line that would then be output in your log environment. So that basically gives you the ability to create dynamic logs, which is pretty cool because as soon as I go and just hit pause, that log line would never happen again. And all the instrumentation is get removed. So you only log what you want when you want. You don't pay in performance for all the log lines that we just generate just to get traceability just because, right? You only do it when you're actually debugging it. But even more, if I would actually expand this, you can actually see the class, the method, and a URL that got injected to this log message. And if I would open that URL, it would actually take me to that specific trace point hit. That is pretty cool because now you can share it in other systems and create all kinds of cool integrations. And now we can actually debug what is going on. So we can see that room 2 is null because we get here and we can see that it's null. Amazing. And available rooms, actually there is 12 of them. And I can go to each one of them and I see it got the right features and the max capacity is 10. So it looks like a good room. The other thing is desired room capacity. So let's search this one, and that is 20. And that is basically the bug, right? We look for a room that was 20 people, but we only find 1 to 10. So we decided not to use rooms at all. Again, stupid bug, but just try to emphasize the point, right? And that really go back to performance. So the performance of trace points and also exception captures, you can actually correlate them to a log message. It's basically the same effort. Actually, it would be a little bit better than log messages because when you create a log, let's say, when you create a log, you're basically serializing all the objects into a JSON format or something like that. And that will, before you can actually move on to continue execute your code. And you do this regardless if that is important or not important to you. Well, the trace points and all the capturing of local variables here is done in 2 phases. First, we do a lightweight cloning, basically still keeping the things in C# word. And then in a different thread, we will then pack everything, decompile, make sure that we get these really nice bug reports and send it to the server. So the impact in throughput is much less, it's lesser than logs, which is pretty cool. And in terms of security, that is awesome. There is security implications because basically what you give your developer is the ability to look into production. And that is a problematic because sometimes there is sensitive information, right? Addresses, credit cards, or maybe SSL tokens or password and things like that. Well, Oscode got you covered for that in two ways. One is PII reduction. So all the local variable values, even HTTP requests and database requests that get recorded, get reducted automatically on the agent, not even sent to the server for collecting. Then the server would actually apply those reduction rules again to make sure that they're up to date. But you can do regular expression, identifiers, and even blacklist complete classes and namespaces. And you can configure it to fit your needs. Another thing that we are offering is an on-prem solution. So basically, if you don't want anything leaving your network, you can do that. And you can then put the server that actually give you this really nice visualization and debugging options to talk. You can deploy it on inside your network and connect the agents to that network. So it basically doesn't hinder your security. The agent itself, you don't need to open any firewall ports and stuff like that. It doesn't accept any income communication. So in terms of security, it's really important. And I think we got really good solutions for that. We'd like to hear your thoughts. If I didn't answer everything, let's see. If PDP deploy, there is also support for source link back to the source control in the dashboard. That is actually a cool feature, and we don't really show you that source link. We don't show you that. What we do show you is if you click on an exception, we will actually give you the build time. And I think there is another thing, the operating system, no, the build time. I think there was in the process name. So that is basically what we will give you right at the moment. So you can say, oh, that will be at this point of time. So this is where the code is. And that really come to solve a different issue. When you try to debug production system, currently you actually need to match your source control in your local machine just to be able to see symbols. And we really try to remove this kind of things. We just try to make it much easier, and we just decompile the code that was actually been here. So you don't really need to worry if you have the right symbols and if you build it at the right time and those type of things. Yes, sounds good. Yes, that is great. So I think I answered most of the questions. And yeah, so let's just summarize. I think that's it, right? Thank you. Yeah. So that is a good summary, right? If you have more questions, then I would be happy to answer them.
Thank you, Idan. For the purpose of the video, we're going to stop there. But I want to keep everyone on. If you want to stay on, we'll answer some more questions in a few more minutes. But for YouTube, just thank you, everyone. If you want to subscribe and like our channel, and obviously we'll see everyone next month. So do subscribe and watch out for our next events. Thank you.